Welcome again, ladies and gents, to another flipped lesson. Today what we're going to focus on is scientific notation, which I know will be a review for some of you, and it'll be a nice refresher for others who haven't seen it in a couple of years. So let's get started. What we're going to focus on first are the two types of data that we do take in chemistry, because we need to pay attention to those throughout the rest of the year. So if you're taking a description or quality of something, it's going to be called your qualitative data. So qualitative is a quality. So it's going to be if something has a smell, or if it has a specific texture, or maybe if it is a color. So that would be more of a quality that you would write down. So that would be qualitative data. If you're measuring something, that's going to be your quantitative data. So these are always going to have a numerical component and some sort of unit on the back. So if you're saying something took 30.2 seconds, or you measured something to be 6.32 meters, or you found a density of something was 21.2 grams per milliliter, those would be your qualitative measurements. And we will use both types in chemistry this year. So it's really important to know whether we're asking for a qualitative description or a quantitative measurement. So let's go ahead and let's talk about the idea of scientific notation now. When we're looking at scientific notation, what we do is we take an integer that falls between 1 and 10, and we multiply it by 10 to some power. And that power represents whether we have a very large number with a lot of zeros or a very small decimal place. So this number n is going to fall between 1 and 10. And this little n up here is going to be a whole number integer. So how do you get that little n? What you do is you count how many decimal places you move your decimal. So if I have a very, very large number like 93 million, what we do is we draw in our decimal place and we move it to the left, and we count as we go. 1, 2, 3, 4, 5, 6, 7. So anytime that you are moving your decimal place to the left, you're going to end up with a positive exponent of 10, because you're taking a very large number and making it smaller by moving that decimal place. So in this case, we would write it as 9.3 times 10 to the 7. So allowing us to write it like this drops all those unnecessary zeros that we don't necessarily need to see. So it just makes that very large number a little bit more manageable for our math. We can do the same thing with a decimal place. If we have a decimal place like this example, we're going to take it and count how many spaces we move it to the right. And in this case, it's 3 spaces. So what we're doing here is we're taking that small number and making it a little bit bigger. So in this case, our exponent is going to have a negative value. So anytime you move the decimal place to the right, your exponent is going to be negative. So in this case, we would write it as 4.3 times 10 to the negative third. So what I'd like you guys to do right now is go ahead, find these examples in your notes, and turn them into proper scientific notation. Hit pause on the video and come on back once you've done those examples. All right, I'm assuming that you've taken the time to go ahead and do those examples, so let's see how you did. This first guy, we're going to go ahead and move it 5 spots. So, oops. So this would become 2.38 times 10 to the 5th. This next example, again, we're going to go ahead and move it to the left. And it's 6 spots, so this would be 1.5 times 10 to the 6th. This next number is a small number, so we're going to move it to the right. So that was 7 spots, so it becomes 4.3 times 10 to the negative 7. And this guy, we're going to move it 2 spots, so he becomes 8.9 times 10 to the negative 2. So that's the first thing we need to be able to do, is to take numbers that are large or small and put them into scientific notation. The second thing we need to be able to do is do this math on our calculators. Now, there's a very important button that you need to familiarize yourself with, and it's this EE button. Depending on what type of calculator you have, it may be found in a couple of different spots. If you have a graphing calculator, it's found above the comma button. If you have a regular scientific notation, a regular scientific calculator, it's going to be found above the X-1 button. And I have to apologize, my dog is currently barking. Sorry about that. So it's just very important that you find where this button is on your calculator. And if you can't find your button, please ask me in class so I can show you where it's located. Now this button is really important because if you're someone who has relied on using your times, a 10, and then a caret, it's going to result in you doing your math problems incorrectly in terms of the order of operations. So you need to make sure that you do use this E button because it's going to result in you getting the correct answer all the time instead of getting the wrong answer sometimes. So how do we do this on our calculator? If we want to take this number, 2.38 times 10 to the fifth, and put it into scientific notation on our calculator, what you're going to do first is you're going to take just the number you find in front and put it in your calculator. So you'd enter 2.38. Then you hit your second button, and then you hit wherever your EE is. What this is going to do on your screen is it's going to write it as 2.38, and then you're going to see this little E come up. That little E equals the times 10. So when you're doing these types of problems on your calculator, you don't need to include this middle part. This middle part goes away from that E. And then after you hit the EE button, you go ahead and hit whatever exponent you have after the 10. So 2.38 times 10 to the fifth would look like 2.38 E5 in your calculator. So I'd like you to try and use that method to do these following math problems. Go ahead and hit pause and then come on back when you're done. All right, I'm assuming that you guys have gone ahead and taken the time to do those problems in your calculator. So I'm going to go ahead and I'm going to finish them up on my calculator just because you guys are a little bit quicker than me. So for this guy here, what you should get if you did it correctly is 3.3256 times 10 to the eighth. And for this guy here, what you should get is 3.668 times 10 to the 15th. So that's just a quick refresher on the scientific method. I hope you found this helpful, and remember, if you've got any questions, you can always come see me for help, especially with that E button. Have a great night, guys.